Hi guys, in this video we are going to see what is binary search with the help of the visual representation, and the same thing we will try to implement in the form of code. So first let's understand what is binary search. In the name itself the search is present. Search is nothing but we are going to search the element from the list of elements. The array will be given and we need to find out the element that we want to search. Okay, so before applying the binary search, uh, we need to take a note that the elements of the array should be sorted, and then only the binary search will be applicable. So for that, let's compare. This is the list of elements that are given and it is in an array format. So these are the total elements that are present inside the array, and we know that the indexing starts from 0. So we had started it from the 0. Two element will have the index as 0 inside the array, and the same thing continues till 91. Okay, so the thing that we need to find out into this list of elements is the number 23. We need to find out the number 23 and return the index at which the 23 is present. So before applying binary search, we need to consider three variables which are low, high, and mid. Low will be the starting point of the array and high will be the ending point of the array. And from low and high, we need to calculate the mid. Okay. So till now we had used four variables, which is key to it says which element we need to find, then low, which will be the starting point, high will be the ending point, and the mid, which we will calculate through low and high. Okay. So let's assign the low and high below the array elements. So 2 will be represented as low and 91 will be represented as high. And we can see that these all the elements are present in the sorted manner from in the ascending order. Okay. So the mid will be calculated as per this formula, which will be given, and it is the same thing that low plus high by 2, because if we sort this out, then it comes out to be low plus high by 2. But if the array indexes are more or else this indexes go beyond the limit of the integer, then this formula comes true, because if we directly do low plus high by 2 and the two numbers are much bigger than the integer capacity, then it exceeds the limit and it will give an garbage value. So that's why we use this formula. Okay, so we need to calculate the mid value as per this formula, and it will come out as 4. Okay, so we will place the mid below the fourth index, which will be below the 16 number. Now the real comparison starts. As we need to find out the number 23, we will compare this 23 with the element that is present at the mid index. Here 16 is present, so we will compare the number 16 with 23, and we can clearly state that 23 is greater than 16. And we also know that it is in a sorted manner, and the number that are present to the left of 16, and we also know that the number that are present to the left of 16 are nothing but smaller than 16. So we can ignore this half, because we know that the 23 is greater than 16 and all the elements to the left of 16 are smaller. So 23 will not be here. It will present to the right half of that 16. So what we do, we just increment the low to mid plus 1, means we just shift this low to the position which is greater than mid position, which will be here, and then we again recalculate the mid, which comes out to be 7. So we shift this mid to the 7th position. Then again this comparison starts. We compare the 23 with the number that is present at mid, which is 56, and it comes out to be 56 is greater than 23, and all the elements that are present to the right side of 56 are greater. So 23 can't be found in this half. We need to look for this half, and we can shift the high to the value which is less than mid, which will be here. Then again we need to calculate the mid, which comes out to be 5. We will place the mid here, and the next step, which is the comparison step, we will compare the 23, and at this particular step we will find out that the 23 is equal to 23, which means we found out the element, and we can return the index at which we hit this comparison. So this index is nothing but 5, and we can state that the element is present at index 5. This was the visual representation of binary search. We will look into the code how we can code this particular thing. So this is the main.cpp file, and we are going to implement the binary search here. So for that, first let's create an array which will have the values as, let's say, 2, 5, 6, 5, 8, 10, and 22. Okay, and we need to find out the value as 10. Inside the array we need to return the index at which 10 is present inside this array. Okay, so first let's try to get the size of array. Then we need to store the result inside the result variable. So for that I will create a method which will be int binary, and here we are going to pass array, then low and high with the key that we want to find. Okay, so first we need to check a condition that while low is less than or equal to high, because if this condition is true then only we are going to search. If high becomes much more less than low, then it will go into the infinite loop, so we don't need this. That's why we put a while condition to check whether this condition holds true. So here we need to calculate the mid, which we had done through the formula, which will be high minus low by 2. Then we will check if array of mid equal to the key that we want to search, then we will return the mid. The mid will be nothing but the index of the array elements. The next condition is if array of mid is less than the key, which will be x. So in this scenario, it means that the array element is less than the key, and we need to find out the elements into the left half. Sorry, the element is greater than that array element, and the element is present into the right half. So in this case, we will reassign the low to the mid plus 1. And the next case is the array of mid is greater than x. So here we need to shift the high value to mid minus 1. Okay. And if this condition doesn't satisfy, then we need to return minus 1. We didn't find out any element, and we need to return out from the loop. Okay. Then we had created a function, and we will pass that function here using binary. We need to pass the array. So the low will be the 0 that we had initially looked into the PPT. The high will be the n minus 1, and the key that we want to find will be x. And here we will check if result is equal to minus 1, then the element is not present in the loop, in the array. else cout result. Okay, so here we are searching for 10, so the answer should be 1 2 3 4 3 0 1 2 3. The answer should return as 3. If we try to run the code, so here we can see the value has returned as 3. And if we try to pass the element which is not present in the loop, suppose such as 13, and if I try to run, it says the element is not present in the array. So in this way we had implemented the binary search. It takes less time than the normal search, linear search. That's why we use binary search, but the condition is that we need to use the sorted array. The only thing that is required in the binary search is the comparison. If this element is less than the key, then we know that the left half doesn't have this 23. We need to look into the right half, then we need to shift this load to the right side. And if the key is less than the element, then we need to shift into the left half. This is the only main thing that we need to do into the binary search. So in this video, we had completed the binary search. The next video will look into such amazing concepts. So for now, bye bye.